when I write out that equation, what do I got to do differently with that one? I got to write squared because what type of x-intercept is that? It's a double root. And how do we know when it's a double root? Right, it bounces off the graph. So right here, it comes down and it kind of just bounces off the graph, kind of glances it, and then goes right back up. Notice on the second one, we've got two of them. Both of them are that way. So when I write out my equation, first, I remember I got to put a to account for the stretch factor. And then for this one, I'm going to write the factor with squared. The second one, I don't need that because it goes straight through. Now, after I set all that up, I got to plug in a point. What point do we use to plug in? Or is most ideal to use? What do you guys think? Because I'm going to have to solve for a as I work through these. So I want to pick an easy point from this graph to be able to plug in other than the x-intercepts. What's that? Okay, so there is a point on this graph that has 0 in it. Which one is it? The x-intercepts have a 0 in it. What other point has a 0 in it? The y-intercept. And what is the y-intercept in this one? 16. So when I plug in my factors, then I'm going to plug in 16 into that to solve for a. And then I'll write out the equation. And we'll go over an example too, how to do this in a second. Again, this is in the Edpuzzle as well for today. Okay, on that second one, I'm going to have a double root. So both of these parentheses should have a what? A square. So I'm going to have a square here and a square here. And what point should I plug in? What y-intercept should I plug in here? Yep, -3. That I'm going to plug in there. Okay, when you guys do the ones below that, it's not going to give you a graph. Obviously, it doesn't give you a graph. It just gives you a point. So you're not plugging in a point with 0. You're plugging in a point that has an x that's different than 0, but it's still the same steps. It's just 0 is obviously easier. If x isn't 0, it's just an extra step of adding or subtracting. Okay, and then the same thing with that last one down there. That's the point you're going to plug in there. And those are your x-intercepts. Now this one right here, this first one, it says it bounces off at -1. So what do we got to make sure we do for that one? Yeah, for that one, we want to make sure we put the square because that's a double root. Okay, so that's that whole first page, and that's really what that. Okay, so let's jump over to Deltamath. And we're going to focus in on this last one. This one yesterday, this is where we had to do the same thing, find the x-intercepts, write out those factors. So for instance, this one's +1. So what would I write down here? X what? -1. Do I put a square or no square? Yeah, because it's a double root. Okay, what about for the second one? X -5, and just, do I need a square? Yeah, they're both double roots. But what's the other step I got to do here before I finish? What's that? The y what? I got to find that. What's that number in the front? What do we call that? The a. So I got to work through the steps, find a point. Now, what point could I plug in to find a? On this one particular. Yeah, you plug in that 0.30 there. Okay, so let's look at an example. Let's find one that's like a double root here. Let's see if I can find one. There's one. Okay, so this one, there's double root at -5 and +2. So there's how you set up your factors, just like we talked about. And then for this one, the y-intercept was 200. So now we're plugging the 0 into the x. And then the y part of it goes on the other side of the equation. And now we're just solving for y. Or sorry, solving for a. So I simplify this. Okay, 0 minus 2, 0 plus 5. Then I square those two numbers. Then I multiply the two numbers. And then I end up with something like this. And just divide. And then I get my a value. And then I plug in the a value to the equation. And notice it's in factored form. I don't have to simplify and put it in standard form. Okay. So for that last one, again, from yesterday, just remember you don't have to put that in standard form. Just leave it in factored form. You can, it'll still accept it if you do, but you don't have to. All right, so let's do this one. Okay. Now, this will give you two different scenarios. It'll either describe it to you, okay, or it's going to give you a table. Okay, so I'm going to kind of show you how to set up this one, but I'm going to more focus on a table example. Okay, so this one, it says the zeros are at -2 and 5. And it says the y-intercept is 30. Okay, it doesn't say anything about it bouncing, okay, off or having a double root. So it's just -2 and 5. Okay, and it says it's a quadratic, and it says to put it in standard form. Okay, so that's the important part here. So here, if it's at -2 and -5, that means that the x-intercepts are at that point. So to set this up, it'd be y equals a times, what do I put for -2? And then how about 5? X minus 5. Now then I'd have to plug this in to find the a. Okay, but again, I want to focus on one that gives you a table just because honestly, that will be the longest example. So I want to make sure I give you guys a good example of that. So let's see if I can find one that gives you the table. There it is. All right, so here's one with the table. So here's where I'm going to focus on. If I'm looking at a table, how do I know if something's an x-intercept? Where is the 0? Is it on the left or the right? The what? It's going to be on the right side. So that column right here on the right, where it says f of x, that's your y. If the 0's on that side, that's an x-intercept. So what's the first one? Okay, we've got -4. What else? 3, 1, and 3. There's 4 of them. Okay, do we have a y-intercept that we can plug in? What is it? Yep, right there. It's basically the same thing, but now 0's on the left. So that's your y-intercept. So we're going to use all those points. So let me write those out. So -4, 0, -3, 0, 1, 0, and 3, 0, and then a y-intercept of 0 minus 72. All right, so let's flip over here. Let me clear that out of the way. Okay. Zoom out a little bit so you can see the whole board. All right, so again, that's the y-intercept. And these are the x-intercepts. All right, so now, let me get a better marker here. Okay, so now when I first set this up, y equals -4, so x plus 4, then x plus 3, then x minus 1. Remember, we're just doing the opposite, and then x minus 3. Okay, so 4 different factors. Now it's time to plug it in. I've been telling you to plug in this number, so let's go ahead and actually do it for this one. Where do I plug in the -72? Well, no, not the a, because that's where we're looking for the a. All right, because this is x, this is y, so we plug it over here. Where do I plug in the 0? Yeah, to all of those x variables. I plug it in there, I plug it in there, and there. Okay. Now, if I'm adding 0 to all of these, it's basically the same number, right? So I'm just going to rewrite it with just the number itself, 0 plus 4, 0 plus 3, 0 plus -1, and then 0 plus -3. Sorry, that's a 3 right there. Okay, now I just got to multiply these out. So -72, 4 times 3, 12, times -1, -12, times -3, positive 36. Okay, and then what's the last step to find the a there? Divide 36. Now what I have noticed with all of these is that you do end up with a whole number, okay, for the a, when everybody's been working out these problems. Okay, so now I have the a. So now I can plug that into the equation. So now I take that a and it goes right in there. And you guys here in class, this is what I'm gonna have you work on right away if you haven't done it already. All right, so here comes the fun part. All right. So it's asking for standard form. What form is this if I leave it like that? That's factored. Because each of those is a factor. Each parenthesis right there is a factor. So it's asking for standard form, which means it's asking you to multiply all these out. But you got to multiply it in steps. You can't just do this all at once. You got to do it one thing at a time. So what we can do is multiply x plus 4 and x plus 3 together. And then we'll do x minus 1 times x minus 3 together. Okay. How do I multiply these together? Okay. Use the box method or FOIL. So let's start with that. Okay, so I got x squared here, 4x there, 3x, and 12. Okay, so remember, don't forget that a value in the front. Bring that down with it, because that's going to be the last step, is multiplying that to everything. So I got x squared. Then I add up my like terms on the inside here. That's 4 plus 3x, so 7x. And then I'm going to do the same thing with this one. You're going to have to do at least 3 boxes. There's one more box coming after this. Okay, so x minus 1, x, and then minus 3. So x squared minus 1x minus 3x, and then negative times negative, positive 3. And take your time when you're doing this. Like, especially when we're dealing with those negatives, double check. Okay, positive times negative, negative. Positive times negative, negative. Negative times negative, positive. Okay, so now x squared. Add those two up, -1 and -3. It's -4x, and then plus 3. Okay. 2 more steps on multiplying. Now, I have to multiply these together. Okay, how do I multiply those? 3 by 3. Another box. These are 2 by 2. I'll write that out. 2 by 2. But this is going to be 3 by 3. Okay, so it's going to probably be the biggest box that you'll have to deal with. So I obviously got to make a little bit bigger box now. And it's going to be a 3 by 3. Okay, so now I start with the first one. Doesn't matter again where you put it. I'll put that one on top. I'm going to put this one on the side. Don't forget the negative. And now I'm going to get 9 numbers, which I got to make sure I add them all up. So first here, x to the fourth. Remember, add the exponents. 4x times 4x squared is negative 4x cubed. Okay, then x squared times 3 is 3x squared. X squared and 7x, 7x cubed. Negative 28x squared. Sorry if you guys can't see that, but that's negative 28 squared. Then 7x times 3 is 21x. 12x squared here. Negative 4 times 12 is negative 48x. And then the last one, 3 times 12 is 36. Okay. Students in the last class, they were using a calculator for every step, which, if you want to just make sure you're right on everything, I would recommend that. All right, so now we got to write this out. Again, don't forget the 2. Okay, so now first, what do I write first? X to the fourth. Remember, start with the biggest exponent. Now that's the only x to the fourth one in there, so there's nothing to add. What comes next? X cubed. Now remember, combine the like terms like in this step. That way you don't have to write out every single one. So 7 minus 4, positive 3x cubed. And what I like to do when I'm dealing with a bigger box is I start like crossing them out just to make sure that like it helps me kind of see what I have to do or what's left to do. Okay, so now add this up, however, whatever works for you. So I'll do 3 minus 28. It's negative 25. And then plus 12, negative 13. Okay, so we're done with those. And then negative 48 plus 21. It's going to be negative 27. Okay, and then the last one, 36. There is one more step. What is the last step here? So again, take your time. And you guys here in class, if you want me to check your work as you're going, let me know. Even you guys at home, if you want me to like check it before you guys submit your answer, feel free. But also just remember you get like one attempt before you have to submit it. Or it'll give you like one chance to get it wrong. Okay, so distribute the negative 2. Oops, wrong pen. Then I get negative 2x to the fourth. Then negative 6x to the cube. Remember, again, check your negatives. Negative, negative here. So positive 26. Negative, negative. Positive 54. Negative, positive. Negative 72. Okay. All right, so let's double check that. So we get it right. So we got negative 2, negative 6, positive 26, positive 54, negative 72. Okay, so we're good. All right. So again, I wanted to show that because I know that that would probably be the longest problem you got to deal with. And again, just make sure that you're changing the signs every time in the first step. Change the signs, flip them around, then figure out the easiest point to plug in, which would be the line intercept. Find your A, plug that in, and then you got to start simplifying, okay, using the box as you work through. Okay, any quick questions before that? What do I need to do to simplify that after I plug that in? Or what does it mean if I have a square? What does that mean for this? It's written twice. It's repeated. So I have to write it out twice. So that means I'm multiplying these two binomials or two factors there. And how would I multiply those two together? Right, work that out with the box. Okay, and simplify that. Okay, then you're going to distribute that 10, and then you're going to have a bunch of single terms. So there will be no more multiplying after that. Okay, then after that, you're going to have to see, okay, after I simplify that, does it equal 29 or negative 29? Now on the second one, It says, without solving, predict another solution to the equation. Okay, so without doing anything, let's just say, I don't know if you guys remember, we were working on the quadratic formula problem yesterday. We ended up with a complex number. If this answer is 5 plus 2y, take a guess as to what the second one would be. What would be the second answer? If it's 5 plus 2y, what would be the second answer? What do you think? No, not 10 plus 4i. Think about when we do the quadratic formula, that when you finish at the end, you always end up with two answers. One, you have to add, and the other, you have to subtract. So if this one is 5 plus 2y, what do you think the other answer is? It's negative. It's the same thing, but instead of plus 2y, it'd be minus 2y. Okay. So by the way, that's just the answer for that one. So I just gave you that one. All right. Okay, this last one here, where does this equation intersect the x-axis? What I want you to do on this one is look at Desmos. So go to Desmos, plug that in, and see what you get. Again, it's asking where does it cross the x-axis? So just answer the question after looking at Desmos for that one. Okay, these ones are like that other day where we talked about identifying the degree of the polynomial. What number is the degree? Or where do you find it? Not how many x's there are. For instance, letter A, what is the degree for this one? What do we need to look at? It's only one number that tells us it's the degree, and it's the biggest what? Exponent. So what is it? 4. So the biggest exponent's going to let us know. You guys remember what coefficients are? Because it's asking you to list them out. What is a coefficient? Or in this problem, what are coefficients? Yeah, so basically, yeah, the numbers in front of the x are being multiplied. So what are the coefficients for this one? What about that one? So you got a 1 and 8. So those are your coefficients. So basically, you're just listing them out. Okay, so you find the degree for all of those. Okay. Last one, these are just solving equations. Notice how we have another square there. So what do you guys think you got to do there first? Just like that other problem. Anytime you got a square, what do you got to do? Write it twice. What could you do first, though, before that? What could I do with that 2? Multiply the 2 by what? Okay, divide. Yep. So divide 2 on both sides. Okay, so that would cancel out, and then I'd end up with x minus 1 times x minus 1 equals 9. You're going to have to multiply that out with the box and then solve the rest. Okay, last one I'll go over is this one. This is very similar to what we've been doing with logs. Okay, I'll give you guys an example over here. So 3x minus 2 equals, let's say, 8. Okay, so take a guess. What do you, or maybe you already know, what could be the first step here to simplify that? Sure, sorry, add 2. Now, the x is in the exponent, which means it's exponential. So what can we do so that we can solve this? So unfortunately, we can't divide the 3 because of the x being in the exponent. If it wasn't in the exponent, we could do that. So the other day, we took logs and we turned them into this form, this exponential, to solve it. But if we're in exponential, we turn it back to log to solve it. So right now, it's in this form, b to the e equals a. So now, let's change it into log. So what letter goes here at the bottom? No. The b, well, 10 is the automatic number, right? You're right about that. But b is the base. What letter goes here or next? Okay, a, and then equal to e. So if I'm going to change this into log form, what goes in there for the b? Or what is the base? 3. What's the a? 10. And then what's the e? X. And then how are we going to figure out that right there? How do we figure out the log base 3 of 10? Calculator. Use Desmos. So that you're just going to use the calculator or Desmos to figure out. It'll be a decimal answer. Okay. Now, I'm not going to go over these last two here, but to review those, go to notes in 3.4. So 3.4, so just remember if you go to the weekly assignment folders right here, where it has that link for the videos, you can look over your notes for 3.4 or scroll down here to 3.4 one variable inequalities, and you can review how to do those. All right, that's all she wrote. Again, if you guys online want to help with that Deltamath problem, if you want to do it now, feel free to stay. I will put back up that example here so you guys can see that and kind of help use that to help you work through it. Otherwise, if you guys are going to take off, then I will see y'all next week.